The Physics of a Tennis Ball by Will Harris, featuring Jake the dog. This is my dog Jake. He's 8 months old and loves to play ball, and will be helping me out in today's video. The next minute or so consists of me throwing a tennis ball at various different angles. Sometimes the ball can be hard to see against the sky, so I apologize for that. The scientific analysis begins at 1:25, so feel free to skip ahead if you get bored. And if you have any issues with the camera work, it was done by my brother, so if you let me know, I'll let him know. I almost hit him here. That was pretty cool, but I missed, so sorry. Alright, thanks, Jake. Everyone say bye-bye. Bye. Whenever a tennis ball is thrown, it becomes a projectile and follows the rules of kinematic equations. Upon release, the tennis ball takes on the trajectory of an upside-down parabola. After release, the ball deaccelerates until it reaches the top of its arc at its maximum height. Here, its velocity is zero as well as its kinetic energy. Although the ball's velocity is always changing, its acceleration caused by gravity is constant. This graph shows the ball's change in velocity. Its highest velocity is when it's first thrown, and it deaccelerates until it turns around and then begins to accelerate back towards the ground. This next graph shows the ball's acceleration, a constant negative 9.8 meters per second due to gravity. Ideally, the ball's horizontal velocity would be constant as well. However, due to other factors such as air resistance, the velocity decreases as the ball continues to travel. Once thrown, the tennis ball begins to face some forces that will help slow it down. The first of these forces is air resistance. Air resistance acts in the opposite direction of the ball's velocity and decreases it. Gravity also affects the ball, constantly deaccelerating it and pulling it back towards the earth. The release angle of the ball plays a big part in how far it goes. The higher the angle, the longer the ball will be in the air. However, you can't just look at how long the ball will be in the air. You have to break the velocity down into components and look at the horizontal and the vertical components to see how far the ball will go in total. Another part of throwing the tennis ball is how it lands. Ideally, the ball would reflect at a complementary angle and maintain its kinetic energy and velocity. However, due to factors like the softness of the ball on the ground as well as friction and air resistance, the ball does not do this. Instead, it reflects at a smaller angle and with less velocity. This departure from the ideal collision is shown obviously when watching the ball collide with the wall. What should have happened in a completely elastic collision would be the ball would reflect and maintain its kinetic energy and velocity. However, obviously this is not the case, as the kinetic energy is not conserved and the ball bounces off at a different angle than expected. If you were paying attention during the videos, you'll notice that I switched up how I threw the balls. Sometimes I use just my hand, and sometimes I use the ball thrower to help me throw the ball. Throwing the ball with my hand results in me throwing it not as far as using the ball thrower. This is because the distance of my hand is shorter compared to that of the ball throwers. Since the forces were the same, this difference of distances resulted in one throw being farther than the other. Using the ball thrower created more torque and allowed me to throw the ball a further distance by using the same amount of force. Well, I appreciate y'all taking the time out of your busy days to watch this video, and I hope you learned something, alright? I also wanted to extend a huge thank you to the cast and crew of this movie. Y'all did such a great job and helped make this film into an instant classic. And finally, I just wanted to make it clear that no tennis balls were harmed in the making of this short film. Additionally, I want to pose a question to the audience. Are tennis balls green or yellow? It's a question I've been asking myself a lot recently, and I'm afraid I just don't know the answer, guys. All right, well, let me know. Y'all have a great rest of your day, and let me know what you thought of the film. All right, bye-bye.